Hi, everyone. Thanks for joining us. While we wait for everyone to settle in, let me begin to tell you a little bit about UCSC Silicon Valley Extension. We offer professional development courses and certificate programs for you to update your skills for today's job market, and we're the leading workforce educator in Silicon Valley. Our courses are designed by experienced instructors who are actually working in their field. We serve new college graduates needing practical skills, people in the workforce looking to update skills or change direction, and lifelong learners interested in studying with industry experts in the heart of Silicon Valley. My name is Monica, and I'm the Outreach and Recruitment Specialist in the Marketing Department. Today's topic is Minimal Python, 5 Python skills you need for data science job with Noah Gift. Noah is a professor, author, trainer, and consultant. He lectures widely on the topics of machine learning and cloud architecture, as well as AWS. He is the founder of Pragmatic AI Labs and has published over 100 technical publications that have appeared in Forbes, IBM, Red Hat, Microsoft, O'Reilly, Pearson, Udacity, Coursera, datascience.com, and DataCamp, as well as multiple books on subjects such as cloud, machine learning, DevOps, and Python. Before I hand it over to him to begin, we ask that if you have any questions during the presentation, please submit them in the Q&A box at the bottom of your screen. He will go over as many as he can after the presentation. And if there are any questions that you think of after the webinar is complete, please feel free to email us at extension@ucsc.edu. I'll enter this information in the chat shortly. Thank you again for joining us, and Noah, I'll hand it over to you to get started.
Let me share my screen real quick here, and let's go ahead and do this. And what I'll start with is this idea of, what are these 5 things that could be helpful immediately? And I think we can cover a lot of them pretty quickly. And so I would say the first thing to really think about here would be writing Python functions. And again, we'll just wait for my mouse here to wake up. Okay, so let's go here. So number 1 would be Python functions. And what's great about Python functions, and we'll go through some hands-on stuff around Python functions, is really, this is the minimal component that you need to do things in machine learning, data science, cloud computing. And a lot of times it's easy to get caught up in maybe someone telling you need to know more than you really do. And so some examples of, I would call this YAGNI, or you ain't gonna need it, would be object-oriented programming, or OO. Really, for data science, is an optional component. Also concurrency, this might be something you've seen before, but really is doing it yourself in Python is not something that is really important, especially for the intermediate phase of doing data science. Another thing that we'll get into is Colab notebooks / Jupyter notebooks. And I think this is a really, really powerful way to get started with Python. And then we'll also talk about source control and GitHub. This is another one I see a lot, is it's easy to get lost and not know the basics of using source control, and it can be very, very helpful. And then cloud. So cloud is something I'm a big proponent of. And in fact, doing data science in the cloud is really one of the ways to do the cutting edge form of data science, because all the data is in the cloud, right? So that's the key component, is that you have infinite CPU, you have infinite storage or disk, and then you also have the ability to use advanced tools. So we'll just say AT, advanced tools. And then finally, DevOps. And DevOps is an interesting component for data science. All this really means is, we'll just say, equals automation. So I feel like these are things that we can cover pretty quickly. And I'll give you a high level overview of each one of these things. So first off, let's just start with, we'll tackle 2 essentially in one go. We'll get into Colab notebooks, which are a form of Jupyter notebook, and then Python functions. So first up, I have a notebook here that I can actually probably put in a chat so that other people can see it, which is in GitHub. And this is part of the minimal let's see here. Actually, it doesn't really matter if we put this in chat or not, but I can. Here we go. Let's just throw this into chat here, this URL. But in a nutshell, this notebook here is in this form of Colab. And first, let me just show you what Colab is. If we go to Colab, it is a hosted Jupyter notebook that comes through Google. And I've noticed in most data science programs I teach at, this is becoming one of the most popular notebooks, and I'll show you why. So what you can do is say File, New Notebook, and you can go there yourself by going to colab.research.google.com. But if we go to New Notebook, the key components here that are actually really powerful are that you can treat it like a Google Doc or like a Google spreadsheet or something like that. So we'll just call this hello, and you know, make this notebook, and then I can add a text cell above here. And then in this case, what I'll do is I'll say, you know, this is my first part, and then I could actually add a few more below here, and we can say, I don't know, ingestion, right, to ingest the data, and then we could add another one here that says EDA for exploratory data analysis, and then maybe another one here that's maybe the modeling. And what happens is that now I actually can collapse these and have this neat structure where I'm able to share my information with other people. And it gets even better in that what I can do here as well is start to write Python code and do machine learning code or import things. And so, for example, I could just say, you know, print hello here and print up something in Python. And what's really awesome about this whole workflow is that you also can share this with other people, just like a Google Doc or like a Google spreadsheet. So what I'm going to do is I'm also going to click share, and I'm going to say change the link to anyone with a link, and so anybody can view this and then make a copy of it, right? So again, if I go share here, I can make anyone on the internet get a copy of this. So I'll copy this, and I'll also throw this into a chat message here. So the Colab notebook is a huge powerhouse to learn Python. Okay, let's shift gears and let's go to the next thing on the list, which is Python functions. So I have this notebook that I checked into source control in this directory called minimal Python. And what we're going to do is go through how to write a function in Python. And notice that I did use the Colab notebook to do this. And as I mentioned before, what I've noticed a lot in people learning Python is they get really frustrated because someone told them they need to do all this advanced computer science. And it turns out that you really do not need to know almost anything that they teach you in a computer science program to be a data scientist. They're actually, even though the word science is in both, they're almost diametrically opposed, because computer science is about the science of computers, and all of this abstract material that works well in a research paper in a PhD program, but really doesn't translate to the real world in terms of building data science projects. And in this particular scenario here, I'll give you an example. This would be a function that you wrote in Python, and notice how it has the word Marco here. And then I accept a parameter, which is name. And just like if you were a kid in the pool, if you ever played Marco Polo, it's the same concept where I look for the word name. And if it says Marco, then it will return back the word polo. So if we go through here, I'm going to go ahead and run this, and I'm going to say Marco, and then I will run it, and we can see it returns back polo. And the reason why is that this variable matches, and then I can return back that value. Now, if I put a different value here, you can notice that nothing happens. And in fact, I could fix this if I wanted to by actually making a new version of this and saying, basically, if I don't get the word Marco, I get something else, say, you know, no, this is incorrect. Right? And so this is one of the core concepts of programming, is that you accept some unit of work, and then you do something based on what gets passed in here. So again, in this scenario here, that's really all that you need to know for most of Python program, at least the stuff that I do, is this concept of a function. And now if you wanted to later play around with this, you could, put if dollars equal rich equal 100, and then return back rich, or you could do anything you want. But I think this is a good thing to play around with. Now let's play with a few other functions that are important to know in Python. You also can build a function that actually just is a placeholder that does nothing. It just executes something. So here's an example of a function called simple Marco. And what I do is really just print something out. So this again is one of the most basic functions that you could write. Now notice that this doesn't return any value. Like in this scenario here, it returns back a value. So it basically, something comes in, some work gets done, and then it returns back a value. In this scenario, all it does is execute something. So there's two kinds of functions in Python. This is a function that takes no input and has no return values. And so if I go and I assign that to a variable, nothing happens, right? The return value is none. And so that's something that's important to know in terms of Python, is that if you don't explicitly put a return value, it'll just return back none, because there's many situations where you don't necessarily need to return something in a function. So let's go to the next section here. Is what about a function that returns without accepting input? So here's an example of that, where I could have a function here where I, again, don't take anything, but I do return something, right? And in this case, what I do is I take the word Marco, and I have an empty quote here next to it, and I add Polo. And then what this does is it returns back that statement, Marco Polo. How do we do this? Well, I assign it to a variable, return medium Marco, and then it goes back and it returns back that value when I print it. So this is another kind of function that you'll see a lot. And again, maybe it does some kind of data processing, or it's some operation that you have to do over and over again. And so a function is a great unit of work that you can use to get stuff done. What about a function that does accept input, but it doesn't return? So this is yet another form of a function that you'll come across. And again, we will accept the word name as the variable inside. And I say, if the name is equal to Marco, we know this, it'll say Polo. Otherwise, we'll add an else statement that says, nice try, no cigar. So inside of here, I tee up that function. And then what I do is I say input Marco, and it returns back Polo, because again, it matched on that variable. Now, if I put in Bob, we can see here that Bob says, nice try, Bob, no cigar. So it put in the other variable here and ran this extra line of code down at the bottom. So it didn't match on this line 2 and 3. Finally, if we put a different person in, we can see the same result. So really, that's the core of writing functions in Python, is that you really can keep it simple. And what I'll show you in a little bit, actually, is that you can do a lot of stuff with just this very simple concept. And I would say maybe 5-10 lines of code for the data science programmer. That's pretty much all you need to know. And I think you've been maybe led astray by if you've ever had a problem where it goes over that. And it's not that that's necessarily a bad thing to know how to do all this really advanced Python. It's just not necessary. And let me just expand on that a little bit. There's an analogy that I like to talk about in terms of learning to program in Python, and I call it the bike riding strategy. And with a bike, if you can imagine when you first learned to ride a bike, that imagine if someone said that in order to ride a bike, you need to have a bike that is, full suspension, and hopefully this looks like a bike. Let's just say that's a bike. This is a full suspension mountain bike that costs $15,000, and in fact, it has you have to have the right shoes, and you have to have carbon fiber frame, and maybe you have to have all the gear as well, like the really fancy bike gear, the outfit. But we know that that's not true, right? You don't need all that. Now, it doesn't hurt. I mean, sure, hey, I'll ride a $15,000 bike with all that stuff. Why not? But that's basically what's been happening. I think a lot with programming is that the full suspension $15,000 mountain bike has been what people have been telling everyone that they need to do. And the reason why is the experts want to ride the $15,000 mountain bike because they've been riding bikes for a while and they're bored. So they tell everybody to do what they're doing. But in reality, you could buy a bike for $25. And in fact, that $25 bike could be a little bit rusty, and maybe it's a steel frame or something like that. And this bike is actually good enough. And in fact, that's all you need to learn to ride a bike. And in fact, maybe even that $25 bike, you can ride it to the store, you can go to school with it. It's in fact good enough for most problems. And so I think the analogy here would be that, and again, what I've seen is that a Python function here is a lot like this steel mountain bike that's $20 or $25 is good enough for almost everything you need to do. And you can accomplish almost everything you'll ever need to accomplish in your entire life by just using Python functions. And then this stuff would be, we'll call this computer science. And the computer science part of Python really is not necessary for most people. It isn't that it's a bad thing, because just like I would really like to ride a $15,000 mountain bike because it looks like fun, it doesn't mean that this is bad. It's just not necessary. And that's been my experience. Okay, so let's go next to the other topic, which would be GitHub. So one of the, and I'll also tee this up with both GitHub and the cloud at the same time. And this is another one that I've seen a lot of students struggle with is onboarding onto a cloud environment. And I think we can do this in literally just a few minutes here. So let me just log in here. And I need to give it auth code. Go ahead and do that. So in the world of data science, a lot of times you're going to come across cloud computing because that's where all the data lives. And so what we're going to do here is we're going to set up a new repository and then pull that into a cloud environment and do a little bit of work with it. So first step, what I'm going to do is I'm going to create a new repo for Python. And what's important here is there's just a couple things. So first step, we'll call this Cloud Python, and maybe write a little description. This is for cloud programming. And really, I would add a README file. That's probably one thing I would add. And then I would add a git ignore for the Python language itself. And here's an example here, Python. And so what this will do is ignore files that are really irritating files, like kind of nuisance files that typically appear. And that's really all you need to do to start with. And here's a repo. In fact, I'll also just share this out so that others can take a look at it. And then now that I've got that set up, I'm going to go to the AWS environment and I'm going to spin up a Cloud Shell. One thing to point out here is that all clouds are pretty similar, that you can open up a cloud-based development environment on Google, Azure, AWS, they're all the same. I'm going to use this one called Cloud9. And what I will do is go ahead and create a new environment here. And this will be essentially like a cloud workspace that will get shut off automatically when I'm done using it. So I'll say Python Cloud here as well and say, this is a sample place to do coding. And they'll give you a bunch of defaults. I just leave them all the defaults here. And it takes about 30 seconds or so, and this will spin up and create a cloud-based environment for me to do a little Python with. So why am I showing you this? Again, what I've experienced is if you're doing data science, that it's good to have a little bit of cloud experience that can help you, build things in the cloud and also, interact with cloud-based environments. And what we're going to do is we're going to check out that repo and put it into this cloud environment and play around with it. So the first thing that we'll do when this actually spins up is I'll need to create an SSH key, which is a way of having bidirectional encrypted communication locally. And then I'll put the public key inside of GitHub so that I can make checkouts back and forth. And why is this so important for beginner Python programmers? One is that it's really easy to make mistakes. And then what happens is that you're getting all kinds of problems in your project, and then you don't know what's happening. And all it would have taken to fix it would be that you could keep your code in version control. So the first thing that you'll need to do in a cloud environment is go here and create SSH keys. So we'll go ahead and do that. We'll say SSH hyphen keygen T RSA. That command right there. And I'll say yes, 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 basically a few times. And notice it says your public key has been saved. I'll just copy that location and print it out to screen. So I'll run the word cat, C-A-T, and do this, just like that. Once I do this, it prints out the public key that I can upload into GitHub. So I'm going to do that next. So I'll copy this and go back to my GitHub account. And I can right click here. Not that. I can just click on this and go to settings. And under the settings, it says SSH and GPG keys. This is where I would put that. So I would name it something. It doesn't matter what it's named. We could just call this Python Cloud. And then paste it in. And notice it even says here what it starts with. So there we go. We paste it in. It'll ask me for my password. So I'll go through here. I'll put in a password. And once it does this, that's all I need. I can go now and I can check out this GitHub repo. So I'm going to clear my screen here and go back to GitHub. And I'm going to click on this green icon where it says code right here. And this green icon, notice how it says SSH. That's the one I want to keep. You can use lots of different ways to connect to GitHub, but if you use the one I just showed you, you don't have to type your password back and forth, and it's encrypted. So I'm going to copy that here. Then I'm going to go back to this location and type git clone and then paste this in just like that. So git clone cloud Python. Now I'll go ahead and say return, and then I'll say yes, and it'll check out the code. So we're in pretty good shape now. We have a cloud environment, we have a GitHub project created, and we can talk to it, right? We've done 3 things. Now, why don't we even write those down? So what do we do first here? I can put those inside of this project in my README file, and I'll say step 1 would be create a repo. And what's neat about this cloud environment here as well is notice how it has syntax highlighting, and it's actually very friendly to me to do Python programming. So first I create a repo. Second, I create a cloud environment. And then third, I would create SSH keys and then load them up. Load to GitHub. There we go. And we're now that we've got that set up, why don't I do my first check-in? So I'm going to cd into this directory that I checked out. And what I will do is just add this change to the README. So how do we know how to do this? If you type in the word git status, it'll show you what files have been changed. In this case, we see the README. So I'll say git add README, and then I'll commit that in. One thing that happens at the beginning here, if we say adding README, is that it'll give you these initial warning messages that only happen once, and you could ignore them if you wanted to, but I typically will like to configure it so that I have a good track record of every time I work with a repository. It's got my name, it's got my email address, so I can do like metrics and things like that. So I'm going to go ahead and paste that in here, and I'm going to put my name in. So this is where you'd put your name, just like that. And then also I will do a email address here as well. So we'll go through here and I'll say this. Okay. And then I'll amend the author. So this is really just cut and paste. You just do what Git tells you to do. And let's just run the command that it told me to do. There we go. And then I will write it out. So I'll do Control O, and this writes that git config out, and then I'll exit it. Once I do this, now I can push my changes to GitHub. So this just committed them locally, but let's go ahead and push those changes, and we'll say git push. Okay, now how do we know this is working? If I go back to this repo here, you can see that we've got the message from the README file. So it's pretty close to being ready now to do Python. So the next thing that I would do if I was working on this project would be that I would go ahead and create a scaffolding. So we'll call this create Python scaffold. And everyone has different ways they like to do this. I have my own technique, and I'll show you my technique, is I will create typically a makefile, a kind of hello.py file, and then a requirements file. And that's really all you need to do. That's like the simplest scaffolding. And so what are these three components? Well, a makefile is really to hold recipes for things. So like if I'm going to run tests, or I'm going to lint my code, or do a deployment or something, I could put all those commands in a makefile. That's why people use makefiles. The hello file.py, that's where the Python code itself would run. And then the requirements file would be where I would put the libraries that I'm using. Now we're missing one other thing as well, which is I would also create a virtual environment in Python. So we'll say 5, create Python virtual environment. So if you do these steps, you're going to get yourself in a great place to program in Python. So let's go ahead and do these. So I'll say first touch, which is a Unix command that makes an empty file. I'll say touch makefile, and I'll say touch hello, and then I'll say touch requirements, right? Just like that. And so that makes these 3 empty files. You can see them: hello, makefile, requirements file. Notice as well that I said create a Python virtual environment, and you may be asking yourself, what is that? Why would I want to create a Python virtual environment? What is it? Well, a lot of times you don't know what's happening on the machine you're on with Python. It could be any version of Python, or it could be, weird libraries installed. And one of the ways to solve that is to create a known good state for your Python code. So if I type in which Python, look, we don't even know what this is. This is just some Python someone put on there. So I want to create a virtual environment that will put all of my libraries, and I can refer to it in one spot. So in order to do that, I'll type in python3-m venv. And what I like to do is I like to put it in an invisible directory by putting a dot in front so that I don't have to look at it. And it won't be checked into my project. So I'll say tilde/dot. And then I like to call it the name of my repo so I don't forget what it is. Just like that. So I'll go ahead and put this into the notes so that other people can see it. And I'll just put that in as a command, just like that. So Python 3, and then you want to activate it. So activate it would be this command. You type in source tilde/dot cloud python bin activate. And what it does is it puts a shell script inside of bin activate once you create that Python virtual environment. So I can just copy this here. So go through here like this. And notice what it does once you activate it is it creates it in this directory. And I also can type in which Python now, and now it's in this directory. So we're really in good shape. Now all we need to do is populate the makefile, the hello file, and the requirements file. Pretty easy to do using this cloud-based editor. What I'm going to do is first go to hello, and we'll just do something really simple. We'll just say def hello, or I'll just say hi, make it different. And I'll make it take an X and a Y, and then this will maybe return back X plus Y. So I guess we could call it add. That might be simpler. Let's call it add. And then I can just print this out. I can just say prints 1 and 1, right? Which should be 2. We can even test this out. Just say Python hello. There you go. 1 and 1. Prints the print the add function. There we go. Print add. I was like, something doesn't look right here. There we go. Print add. And there we go, 2. So we print out 2 here. Now that I've got this working, I've got enough to create the rest of the scaffolding. And what I'll do is copy some stuff I've done previously. So I have a project here called PyTest that I'll just pull up real quick, called PyTest, GitHub Actions PyTest. And so this is a previous project that I've used, that I usually copy things off of. And notice there's a makefile here, and I can just grab some of the stuff out of here. And so I'll grab this, which is an install section. So grab here, go to makefile. And so all this is going to do is it's going to make something that's really irritating and tedious, and it's going to make it so that all I need to do is say make install. And then I'm going to add one other thing, which is a lint command, this, and I'm going to add this in. And the reason for doing this is not to create complexity, it's to diminish complexity, is that I can't be bothered with all this stuff. It's like, I don't want to do this. I just want to do something really simple to install my code and to lint it, which is make sure that the code is actually correct. And what I will do here is add inside the requirements file that library, which is pylint. How do I use a makefile? I just need to type in make space install. So let's go ahead and clear our screen here, and let's test it out. Make space install. The make file understands a command called make. It's on every Linux system that's out there. If I go through here, it goes through and it installs this package for me. So I could use it to install scikit-learn or pandas or Flask or whatever I wanted to install. Now, if I want to lint this, I can just type in make lint. Same thing. It just simplifies something that's really, in my opinion, boring, is doing this. You might be asking yourself, wait a second, why do I want to lint my code? What is that for? Well, one of the reasons why it's important to do linting is, here's a good example. What if I forgot that I put some bad code up here, and I was going to put something and I forgot, and I got distracted, my pet downstairs is barking or something. Well, let's go ahead and do make lint. Notice what it does. Uh-oh, we got a problem. So it tells you exactly the line of code that's got a problem, and it automatically checks it for you. So that's why people use lint. So there we go. We got pretty much everything set up here. I'll just comment that out. We have the scaffolding set up, right? We've got the virtual environment. We've activated it. And then we've linted code locally, right? So that's pretty much a good Python project that I would say universally every Python project should probably have this. I would say everyone in the whole world should have this. All 100 million Python programmers, or however many there are. So now let's go ahead and say get status, and let's check in those files. So I'm going to add in the README, the make file, the hello file, and the requirements file. So we'll say get add README, get add make file, get add hello.py, get add requirements. Once I do this, if I say status, all 4 should be green now. They'll say that they're ready to be committed. So I'll say get commit, and these will push these locally into the local Git repository. We'll say these are my scaffold files, and then we'll push. And then if I go back to my notebook here, and I go to this directory, we can say Python what did I do? Cloud or Cloud Python or Python Cloud. Forget what I called this thing, but it should be in my repo here. I can just say, yeah, Cloud Python. Okay, there, that's what it is. So we'll say Cloud Python. Now that I've got these checked in, remember I said there's a fifth step, which would be DevOps. What DevOps really is automation, and every Python programmer should know a little bit about this. So what we're going to do is the step that I did locally, which is make sure my code doesn't break, and also made sure that my packages are installed. I'm going to do it automatically. So what I'm going to do is click on this icon here, Actions. And if I click on icon Actions, this will let me do anything I want inside of GitHub Actions. It can run things automatically. So I'm going to say, set up a workflow myself. It gives me this template, but I'm going to delete it because there's more code than I need in here. And I have already an example of this in another project. What I'm going to do is copy this as a template and replace it. So we'll go here and I'll copy all this and then just throw this in there. And so let's go to this workflow here. And all it does is that it literally just runs the same commands that I was running in the Cloud Shell, but it does them automatically every time I make a change to my project. So this is really, really helpful in that I always know my code will be in a good state. There's a bunch of things we can do, but I'm only going to do the installation and the linting step. So I'm going to go ahead and say start commit, and I'll say create GitHub action. And there we go. This will commit. And what will happen is if I click back on actions, it will start a job here in a second where it will test my code automatically. There we go. Create GitHub action and click on the build. And then this build will set up a job, set up a Python 3.8 environment, install my packages, lint with Python, and then show me that it's good. So this is really like a robot. It would be like a robot vacuum cleaner, but for your project. If I go back here, I can select this icon and say create status badge as well. And it will give me some markdown code, which is the format that README's in. And I can go back to this and I can actually just paste this in at the top. And this will show me that my project is good. So it's kind of like a, you know, I have gold stars, and then I will commit. Perfect. Now, let me go back to the cloud environment here and then pull the code. And this will just grab that template file for the GitHub Actions. Now let me show you, let's uncomment what happens let's just say again, I accidentally forgot to check this code and it's all broken, right? We know if we do a lint, it'll break. And I'm working with a bunch of other data scientists here. They would be very upset if I broke up everything. And so let me show you why the GitHub Actions is so powerful. It can stop, it can notify you that you made a problem in the code, and it exactly will tell you what happened. So I'm going to say git status. I'm going to add this, commit it, adding broken code, and then what will happen is that the GitHub Actions will run because I checked in a new change. If I go here, we'll see it'll trigger a new change adding broken code. And this time it's not going to pass because the lint will catch this, that I have a syntax error. And the syntax error will be quite problematic in that it will blow up my code right here. And we install the dependencies. And then boom, it breaks, right? So it even tells me exactly what happened. So this is really helpful to other people on my team, to me, right? As I'm always checking that everything is going correctly. And also if I go back to the README file, this will eventually wake up and it will actually turn red and it'll be like, uh-oh, you've got a problem with your code. So what we can do to fix this, in fact, we can even fix it inside of GitHub, which is a neat little trick. If I go here to this edit file, I can comment this out and fix the code. All right, so that is basically going to fix it. And I go here, update it, and we should run one more time. It should work. Let's take a look. It's building. Installing the dependencies. And job's complete. Perfect. So let's summarize then everything that we did. If you remember here, we had 5 things that were important to a Python programmer. And let's just double check our knowledge here. So first up, we talked about the Python function itself, which is one of the most powerful techniques in Python. And the main reason why it's so powerful is that it is a version of simplification, right? With a Python function, the core idea here is that you're doing less work. It's basically the beach cruiser, right? It's the $25 bike. You don't need to do everything that the mountain bike does that costs $15,000. It's good enough. Then the second thing we got into was the Colab notebook. And Colab, what's great about Colab is it's a hosted version of Jupyter. Most data scientists now are using something like Colab or using Colab. And then we also got into GitHub, which is really a misunderstood tool. I think many people do not use source control because they think it's too much work, but it actually is less work because it saves you time and really lets you keep track of things. It's like a backup system. We also talked about the cloud, which also is a little bit misunderstood in that a lot of times, there's this misunderstanding about the cost of using the cloud, and the things that I showed you are effectively free because they're low cost resources that auto time out. And then the other thing about the cloud is that that's probably where the data lives. And then finally we got into DevOps, which is really a complicated way of saying automation. And all of these are little tricks that are not as frequently talked about, but can really bring you to the next level. And these are definitely things that I'm very passionate about and can expand on more. So that's probably a good spot to maybe go back to some questions here. And maybe that's something that I can stop sharing my screen for a bit and kind of get back into question mode here. So let's see, the first question that I see is, so Python is a must know for data science. What about R and any other language? So I think, yes, Python would be a must for data science. And the reason why is I would say it's like an 80-20 or even like an 80-20 and then maybe, or 80-19 and 1, where there's like 1% of the code would be something very exotic, like, Java, C++, Julia, there's these really, really small data science use cases for those languages. Like if you were going to work on the TensorFlow package itself at Google, then most likely you would need to know C++, but that's a very, very small group of population. And then in terms of R, the reason why it's got a fairly wide adoption, I actually like R a lot, but R is more of an academic type language, and that where you'll see it heavily used is by professors who are writing research papers where they're doing mathematical notation and, doing abstracts and things like that. And R is very conducive to that. And where you see Python in the 80% use case would be that in industry, R is not a widely used language for developing software, right? And that's just the truth, is that as good as R is at statistical functions, which I really like R again, it's not used for building GUIs, for building web apps, for building, cloud computing modules. And so it's that combination of Python plus the fact that it's widely distributed across pretty much every domain. That makes it, as a data science language, very appealing. So if you wanted I guess the widest variety of jobs available to you, I would focus on Python. I would use the bike analogy again, where it doesn't hurt to have Python and R, right? Where that would be like the mountain bike, where why not? Why not have two bikes? Why not have a bike that gets you around and then also a really fancy one? But I would say if you want to just focus on just one language, probably the biggest ROI right now is Python. Now, in terms of another question is, in cloud computing, do we have to do all the steps that you described for every Python code that we created? So not all of those steps. That's the stuff that I described is just the initial project creation. And I would recommend doing the first time you set up a cloud environment, doing some of that, creating the SSH keys, getting hooked up, creating the scaffolding. But then once you set it up, you could be working on the project for 4 years and you never have to make those changes again. You've essentially set up a foundation of automation that will really help you out and save you time in the future. Another question here is, does it mean that AWS Cloud9 is no different than Azure Cloud Shell and Google Cloud Shell? Yes, that's exactly right. So really there's very little difference between AWS Cloud9, Azure Cloud Shell, and Google Cloud Shell. They're pretty much the same thing. And what you'll notice with cloud computing is that most cloud vendors are like copying each other left and right. It's almost like a rule that if one cloud provider is doing something, the other one either is going to do it in the future or does it right now. And so in a way, it's actually fairly easy to learn multiple clouds because you can count on whatever you learned will probably be available in another cloud. Another question here is, can you talk about how prevalent data visualization is for data science projects and the leading players, Pandas, Matplotlib, Seaborn, Plotly, PyGal, or others? Thanks. Yeah, I think in a way, data visualization is commodity now. And in fact, a lot of the cloud platforms, the machine learning platforms themselves do a better job of what those open source libraries do with a lot of work. So for example, if I wanted to go into a project and plot, exploratory data analysis and scatter plots and all that kind of stuff, then yeah, Matplotlib, Seaborn, Plotly, I love all those libraries. They're very, very helpful. If I was going to create an article or a book out of those, which I have, then those would be a good use case. If I'm just analyzing data though for my company, it may be the case that I don't even touch the exploratory data analysis anymore if I'm using the cloud. I think the cloud has a lot of automatic visualization tools that will solve that. Good question. And does minimal Python cover the 11 steps you went through? Yeah, so that's really something that I cover that heavily in most of the books that I write is this idea of creating a known good pathway so that you don't get yourself into trouble. And that the book actually is really about how do I know just what I need to know to be effective, and then what do I not care about? And that's really the spirit of the minimal Python book, is that I'm essentially teaching you to actually buy the $25 beach cruiser. It's good enough. Another question, are you going to touch on statistics principles in the Python specialization course, or are there several courses in the specialization? Yeah, I think the basics of statistics are something that are inherent to the concept of Python for data science. And so some of the principles of median, max, min, quartiles, data distributions are things that come up, fairly regularly, and it's kind of integrated into, the way that we would do Python. Good question. And how about Oracle Cloud compared to AWS GCP? My team would need to use OCI instead of AWS GCP for our Python code. Sure. Yeah, I think I don't. One of the things I think that at this point with the cloud is that, first of all, Python itself doesn't care where you run it. It can run in the cloud, it can run on your laptop, it can run on Raspberry Pi, it can run on, devices, hardware. So nothing that in this course in particular that we would study would have anything to do with any particular cloud at all. It would be agnostic and in fact, generic. And that's just for time's sake, I didn't show you that we could have done the same thing on 3 clouds at the same time. But everything I showed you is not really inherent to any cloud platform. Let's see, does the program offer help for seeking jobs after finishing? That would be something that I believe that the program can talk about, but I will say just holistically that one of the things I'm really passionate about is helping people get jobs. And I think if you create a rich portfolio of work in the language that you're building your projects in, I think that's a great way to get a job, plus a certification, which is something that's offered here. I think those are 2 of the best techniques combined together to get a job. Another question is, the way you showed AWS usage, ease of use, will it be similar to OCI? I have less experience with the Oracle Cloud, but as I mentioned before, there's no reason that what we covered wouldn't work on any cloud, and especially because even the cloud itself is becoming commoditized to container-based workflow. So if you think about what we just did, it's just a container, right? We're running on a container that gets launched and we're putting some stuff inside of it. So really Python itself is an ideal language that doesn't matter about where you're running it. Yeah, and by the way, I'm actually a huge fan of running code in any possible place it can run. I'm fairly neutral about which cloud is the best cloud.
It looks like there's all the questions that have come in so far. Thanks so much, Noah. Thank you for doing a brief overview of this. And I think it was really helpful for everyone to see a preview of what your course will be like. For everyone, it does start on October 5th, and I've sent some links in the chat. After this, we did have another webinar yesterday, so I'll be sending both recordings by tomorrow. And you can all just check your email that you used to register for this webinar for those recordings and for these links. And it looks like one more question actually came in, Noah.
Sure. So one question is, would a web developer find the contents covered in minimal Python relevant? I would say yes. So the thing that we covered today, for example, that I feel like is really important to know that we cover in the book is why are you doing things? And that's actually even an existential question that everyone should ask themselves, is why am I doing what I'm doing? And almost on a daily basis, like, why am I here? So the same thing is, if you're writing all this code in Python, is why are you writing all this code? A lot of web frameworks in particular like to force you to do really complex object-oriented programming, but there are frameworks where you don't have to, in particular Flask, which we go into in the book. And with Flask, you just need to write a function and put a decorator on top, which is another function in Python. And in, let's say, 10 lines of code, you can have a web service.
Well, I guess there's no more questions. Thank you again, Noah. Thank you for your time.
Sure.
Thanks everyone for
Okay.
participating. Excellent.
Talk to everyone later.